It's my great pleasure to introduce the Alfred C. Redfield Lifetime Achievement Award. This is an award that has been presented to an ASLO member since 1994. The Lifetime Achievement Award recognizes and honors major long-term achievements in the fields of limnology and oceanography, including research, education, and service to the community and society. You see the list of illustrious awardees over on your right. And it's my pleasure to introduce Carol Robinson of the University of East Anglia, who will introduce our 2009 awardee. Carol?
Good morning, everybody. Well, it gives me an enormous pleasure to be able to introduce the recipient of the Redfield Lifetime Achievement Award for this year, my mentor, friend and colleague, Professor Peter Williams. Now, as John has already mentioned, the Lifetime Achievement Award recognises major long-term achievements in the field of limnology and oceanography, including research, education and service to the community and society. Peter's 45-year career has focused on understanding the variability in plankton production and respiration and the dynamics of dissolved organic matter in the sea. He was one of a small group of scientists who initiated and led research into what we now call the microbial loop, and he's also made significant contributions to debates on the metabolic balance of the ocean and the measurement of production and respiration. Peter has taught, inspired and mentored undergraduate and postgraduate students and postdoctoral researchers for over 40 years. He's also co-edited several leading textbooks, at least 3 of which are on sale outside at the moment. And he enjoys communicating his interest in the history of scientific thought through, appropriately enough, a biography of Redfield, which was published in ASLO News recently, and also organising a conference to celebrate 50 years of measurements of primary production since the introduction of the C14 technique by Steeman Nielsen. These incredible research achievements are also augmented by Peter's dedicated service to the community and to society. This is evidenced through his leadership of a UK research programme, PRIME, Plankton Reactivity in the Marine Environment, his contribution to numerous international committees, including the ASLO board, and also his successful organisation of Plankton as Art exhibition at a recent ASLO meeting. Now, I was struck by Michael Pace's citation from Evelyn Hutchinson yesterday, essentially saying that the best scientific interpretation is often done by those who know the feel of a messenger tripping a Niskin bottle on a wire, which I took to mean those that have a particular practical connection with the environment in which we work. And I felt that this ideally summed up the combination of Peter's practical and intellectual skills. His ability to design, build and implement high precision analytical equipment is well known. And you see here his instrumentation that has been developed to measure dissolved inorganic carbon and oxygen in seawater. These photographs are almost 20 years old, yet the instrumentation is so robust that coupled to new computers and software, they're both still going strong. And ecotypes or clades of this instrumentation now exists in a wide range of departments and universities and laboratories in Europe. And these are just some of the publications that Peter has published based on data derived from information from these instrumentation. Peter also has turned his hand to developing and building an in situ rig. Here, these Dexian cubes, affectionately known as Peter's chicken cages, or on the Marion Dufresne, the cage or pool, were designed in order to incubate samples for a wide range of plankton metabolic processes, and also to protect our precious oxygen bottles. Much to the amusement of the officers and crew on the ships where we deployed these Dexian cubes were tied together with climbing rope and attached to a surface buoy with bungee elastic. However, Peter always got the last laugh because data derived from these incubation rigs were later published in both Nature and Science. Peter co-led a research cruise during the North Atlantic Bloom experiment in 1989, and here his plumbing expertise was used to the fore. So one of the things that we were trying to do was to measure a range of biogeochemical parameters at high spatial resolution to look at the drawdown of carbon dioxide linked to the growth of the phytoplankton. So Peter designed a system whereby seawater was pumped into a header tank on the upper deck of the ship, which then gravity-fed water into the main laboratory below and to instrumentation, individual instruments. The network of tubing was tied to the ceiling of the laboratory, and Peter inserted water wheels which spun to show us that the water was flowing correctly. Inevitably, just as a domestic heating system sometimes breaks down and has airlocks, this network of tubing sometimes didn't work. And Peter was then in his element organising groups of us to untie the tubing from the ceiling of the laboratory and realign the tubing relative to each other to get rid of the air bubbles. This really has to be seen to be appreciated, but I can tell you that it's an excellent team-building exercise to do every morning at about 2 o'clock. Again, both his practical skills and his scientific intellectual skills were combined to produce 2 Nature papers, and on the occasion of his retirement, he was awarded the one and only NARBE plumbing certificate. So I hope in the limited amount of time available, I've been able to give you a flavour of the scientific excellence of Peter, his sense of humour, his passion for science and his passion for communicating science, which I believe makes him an ideal candidate for this award. So I'd now like to ask Carlos and Peter to come onto the stage so that Carlos, as President of the Society, can award Peter this incredibly well-deserved award. Thank you.
Same as on teeth.
Yes. Hello, good morning. The Lifetime Achievement Award that Peter Williams is about to receive consists of 2 items. One is a plaque engraved with his name and the citation, which I am about to read. And the other one is a wonderful book on the biography of Alfred Redfield, which I encourage you to read. It is really an outstanding book and a piece of research, because the author of the book interviewed the daughter of Alfred Redfield and went through piles and stacks of letters and materials in order to compile the biography of this outstanding scientist. But I actually have no hopes that Peter will read it, because he happened to be the author of this piece of research. But he will get a copy anyway.
Maybe you sign it for me.
I'll sign it as well. So it is my pleasure and honor to present Peter Williams, whom I have the highest appreciation as a scientist and a colleague, with the Alfred Redfield Lifetime Achievement Award, and it is presented to him for his outstanding contribution to our understanding of oceanic productivity, carbon cycling, and metabolic balance, and for his role in shaping current views of the importance of microbial processes in the ocean. So,
Well, Carlos, thank you very much.
thank you. Thank you. Congratulations.
That's a pushing approach. Yes. Thank you very much. Well, it's a very great honour to receive this award, and I can tell you there's a great element of disbelief as well. It means a great deal that it comes from ASLO, and the reason for this, and I think many scientists of my generation would understand this, is although I'm very much a committed European, my intellectual home has been very much in North America, and many of my, not all obviously, but many of my colleagues have been American, so North American, shall we say. And so it's very fitting from my point of view that it should come from a society that has deep roots in North America. So I thank you all, and I thank you, we're all a product of our friends, family and colleagues. So in many respects, it's them that also thank you for the award as well, because they have contributed greatly. And at the end of my performance, all assuming I get there, and Sandy's biting her fingernails over this at the present, we'll have a little somewhat idiosyncratic celebration for this group of people who've helped me and led me and guided me and whipped me into shape over the years. There was a time. Oh, no, I want to start here. We all, I think, our vanity very much makes us enjoy and hope that some of the comments that are attributed to us are appropriate. But at the same time, we all have this little quiet voice at the back which says, are you really sure, Peter? Are you sure they haven't got the wrong man? And there was a time, how do we move the slides? Does this do it? Yes, okay. There was a time when that question, sadly past, that question would have been very appropriate because I had a very distinguished namesake, Peter M. Williams, and the M becomes very significant in a minute. And I worked with him back in the turn of the 60s and 70s. And some of you will know Pete Williams. He's a lovely, down-to-earth, crusty Yankee. He came from a Connecticut farming family, no nonsense at all. And when I returned to the UK, I got this letter I've always cherished from him, which started off, "Dear Junior." It sort of put me in my place. He said, I, that's Peter M., was christened Peter Montague Williams, which he wrote, I thought was a pretty stupid name until I saw yours. So I've been many times asked where this funny LeBee comes from, and it comes from this crusty old buzzard, which is my grandfather, Charlie Le Breton. Charlie was a staunch Stalinist, sorry about that, arch anti-royalist, well, maybe you got a point, and definitely a signed-up member of the Awkward Squad. And somewhere in the audience he should be, unless he's gone off with a rather attractive young woman I saw him with last, is my son. So these genes, I can assure you, run very strong in the family. So what did go on in my watch, and I want to, if I can find the time, talk about two things, actually. One was the revision of the paradigm of the role of microorganisms in the plankton food chain, food web. And I want to talk about this as a paradigm change, because I think that is the interesting thing to look back upon. And what you should do is think of also the first lecture we had this week by Mimi Cole, which was also about a paradigm shift as well. And I think that the shifts in the two cases were quite different, and it would be quite interesting to sit down and try to puzzle that through and try and work out why that should be the case. The second thing, and I have something of a suspicion I'm not going to get to it, is I'd like to talk about presently this unresolved debate, I think, over the balance of organic material in the oligotrophic oceans, because I think there are some very interesting things, not about the original question that we asked, but about other aspects of making measurements at sea that we shall learn from this. The pre-existing role of bacteria, so if we start off with a microbial loop, The organisms were low in numbers, they were slowly dividing, they were eking out an existence, the broad conclusion was marine microorganisms, along with marine microbiologists, were regarded as of little consequence and largely could be disregarded. Fortunately, I think that is changed. And the basis for this was our estimate of numbers. Our estimate of numbers was deeply flawed. We could only account for a few thousandths or even less of a microgram of bacterial or microbial biomass in the water, when in order to drive the system, we would need about 1,000 times more. And there was no way you could get the argument through unless that circumstance changed. Now, I think you might identify 5 phases in the development. You have to identify the problem first. In retrospect, that might seem a very simple thing, but it's not when you're in the middle of it. The methods had to be developed, the data gathered, then syntheses had to be made, and then the evolved view within that specialized community had to be broadcast to the community at large. And I see those as separate steps. And then there's the last phase where the more reactive elements, human elements, of the scientific community were eventually, in most cases, converted. And, yes, the line does show up. The events above the line took about a decade and a half, and the event below the line took just about the same length of time. There's an old lovely English saying that there's none so deaf as those that won't listen, and there was a large element of that, I can assure you. If we go to identifying the problem, I think without question, there was a beautiful paper by Larry Pomeroy, very difficult to get it published, and that is another problem associated with paradigm shifts. That was published in 1974, and that crystallized the problem in a very elegant way, because all the processes inside the circle were the conventional paradigm. The processes outside were the new and developing ideas. It was a very, very, very clever diagram. Then, or concurrently actually, methods had to be developed and data gathered. And it was a very, very yeasty time. A lot of ideas came out. John Hobby made a comment a year or so back saying that almost any wacky idea was accepted and considered seriously at that point in time. So we had a whole slew of methods coming out from a variety of people. It was the whole community were not actually operating together. Largely were operating independently, it seems to me, although there were connections periodically, but following the same track, presumably with the same motivation. If you look at the various theories of paradigm shifts, you can take the classical view of Popper, where a hypothesis is rejected and we move on to a new one. And any one of those observations, in principle, could have rejected the previous hypothesis. But it didn't happen that way. You needed the whole weight of them to shift the view. And that's more akin to the sort of alternative theory of paradigm shifts by Thomas Kuhn, which, if you put it very crudely, you have to beat the previous hypothesis into a pulp before the new one is accepted. Critical in this system was we had to get the measurement of bacterial numbers right. That was achieved by John Hobby and Ralph Daly. A number of people obviously went out and made the field observations, but that was Hobby's, one of John Hobby's contributions, one of John Hobby's many contributions. And he was very rightly acknowledged for this last year with the same award. And that shifted us from a number which was impossible to drive the system to one where we could at least now put arguments together on how the system could operate in a different set in a different paradigm. But then a whole series of syntheses were made, meetings were held. There was one that John Hobby and I ran in Portugal. A number of papers came out, and you could look for any one of these papers that could have actually driven through the new paradigm. There was, in fact, an article by Bruce Peterson in that particular volume, which was a very radical model. The most radical one actually came from Yuri Sorokin, a Russian. That was, in fact, in 1978. The details you may not be able to see, but I've overwritten them a little bit. And that is as accurate as a modern rendition of the interactions with the food web as you will get. And the interesting thing, about 45 years ago it was written, 45 citations to date. And as I say, it was absolutely radical. The very interesting thing, and the thing we haven't got to the bottom of, and Tom Anderson's at Southampton, the Eastern Bloc community didn't go through the previous paradigm. They had what we would regard as the contemporary paradigm. That was in their mindset. So in some respects, Sorokin was reporting what he had expected to be the case for 20, 30, 40, 50 years. And it's not entirely clear to us why the Western Bloc and the Eastern Bloc had these two different paradigms, how they arrived at it. We certainly arrived at the wrong paradigm for the wrong observations. Whether the Russians arrived at the right paradigm for the right reason or the wrong reason was not entirely sure. Whereas I think there were a number of possible papers that came out where you could say, well, they were in-depth analyses, and these, if you like, stated the paradigm. I wrote a couple of papers, and Ducklow and Tom Fenshel. I think without doubt, the broadcasting of the view to the public at large, there was one paper, and as we all know, achieved that, and that was by the group with Azam as the first author. And that also came out of a NATO symposium. So NATO does other things than rattle swords. And it was a little tiny group that was put together. They sat on a little table drinking. The meeting was in Bordeaux, in Bombane, and they sat down drinking wine and just went over this. And if you are looking to write an impact paper, this, I think, is the absolute model that you should look at. It was concise, it focused on the issue, it didn't get lost in long, complex arguments about data and such like. It had a very strong authorship, it was in a frontline journal, and it had a catchy title, Microbial Loop. And as I say, it was a model as far as that's concerned. And it was acknowledged by the Society in 2006, if I remember rightly, as an outstanding paper. It got the John Martin Award. And it's interesting to look at other people associated with this work who have received awards. So the Society, I think, has acknowledged that tremendous output of creativity that occurred during that time. Well, I'm looking at my watch, and I shall have to cut out the whole next section, so forgive me while I flip through the slides. I'll just pass by one, which is one of Carol, which between these various times we were involved in other activities, and you can see Carol there working in a cowshed, looking out the window, and we should have a little bubble. What on earth, name, am I doing here? So I'm going to skip the next part because there's no point trying to hurry through it. It's a lovely story, and we'll have to tell it another time. And I want to go to the end. I have to go carefully here. And in the closing minutes, I want to have, as I say, a fanfare. It's a celebration, and we should celebrate our colleagues who helped us through this. So in a rather idiosyncratic way, I'm going to have a fanfare for friends, family, and colleagues. And I have to look to the technologists and to ask for the music, maestro. Farouk? Oh, I've got to do this. That's right. Judy Davis, Morton Sondergaard, Verdun, John Raven, John Mara, Carolyn Glenn, two friends, Duncan Purdy, Jed, two friends, Bob and Hill, Maha Kalaja, physical chemist who's worked with me a lot, Javier Aristegui, Peter M. Williams, John Cole, Dominique Lefebvre, Carol, Mike Fasham, Tim Hollybull, Paul Morris, John Hobby, Hugh Ducklow, Tom Anderson, my student Dylan, Auntie Helen Schneider. There we go. Come on. Oh, that's Carlos, Dennis Burton, Tom Fenchel, Gaynor Evans, Carol Jansen, Tony Knapp, Paul Del Giorgio, Tracy Bentley, Charlie Ench, Bo Riemann, John Beardall, Dave Carl, Larry Pomeroy, my family, the latest Charlie LeBreton, and many of you will have recognized the tableau that I've created. So we have the next track, please. So they've all been, as far as I can, carefully placed against their appropriate members, and you can read through the list. And finally, thank you all too, because without an audience there's no performance. Thank you very much.